Exciting. And are you ready for the live stream delay? The daily live stream delay?
I've been listening something about how he's not taking class today.
You what?
Evan texted me and said that he said he's not taking class and he wants his notes and homework.
All right, so the notes are the same as yesterday. It's this big giant thing, and we're not really going to do notes today because we're probably not going to have time, but it's in there and it's important. The homework is going to be this thing. Okay, so there you go. And I'll pass this out to everybody. It's just algebra.
Fractions.
No, fractions aren't as scary as you think they are.
Yeah, but I don't like them.
I know. I understand why you don't
Never
like
have.
them. It's because teachers teach you them in the worst way possible.
It's like
And I
the
understand why they
boogeyman.
do. I understand why they do.
Especially with Miss Wayne, which was our junior high teacher.
Yeah, well, I mean, they do it for a reason. They don't do it maliciously. They really do mean well. Everybody's.
Can I solve your 3x3?
You can if you want, yeah.
That's cool.
Let's get rid of. Okay, we are muted. Good.
The last time I saw you,
I don't know.
it was a long time ago. And I got sick and I was gone. I didn't even
You were getting sick. It was like a long, drawn-out process of becoming sick too. It was like
it was
see it from a mile away. You are on the mend or no?
better.
Yeah.
I'm better.
Okay, better is always good.
Yeah,
That's okay.
but I'm getting worse, Mr. Mac.
Yeah, that's not good. So we get a drink.
No, I'm gonna fill this up.
That's what I meant.
Alright.
So today, this is the warm-up. I'm going to explain it because we haven't done anything like it yet. So once again, because I don't have my class camera, which every day I regret more and more not having because there's so much more to the lesson than just what's on this dumb piece of paper. It's getting missed. I don't know how to. I'm trying to think of a way I can get that there. I guess I could print it. I guess I'll print it. We'll try printing it. I'll explain it. We're doing an algebra review this week. No quiz this week. Can I print? Yes,
So
I
why
can.
didn't you have it?
No homework. No.
Oh, great.
All right. Can I make this bigger
Do you
though?
have the notes written out? Do you have notes yesterday?
Yeah, we did. Here they are. They're just like a giant algebra review.
Can I go fill my water?
Go! Hurry! All right. I need to explain how.
Mr. Mac, I'm a professional like bottle paper in my hand.
Yeah, really?
It's
Wow.
natural.
Amazing. Of all the things you could be talented at, I think that's the worst to put your points into. All right. So here's the deal. Why is everyone gone?
At least I'm good at geometry.
Because I got them sick.
Okay, that's not good.
Yeah,
Stop
Mr.
doing
Mac,
that.
it's me.
But I'm not gonna miss
I'm
Nancy.
kidding.
All right.
I don't
Nancy
wanna
too.
take
That's
classes.
good. Evan is not.
It's the orthobus.
Wait, Mr. Mac, if
With the what?
we
The ortho bus.
What does that mean?
There's a bunch of kids that go on a bus together if you go to the orthodontist.
Oh, that's adorable. Oh man, do they get like matching rubber bands?
would I get extra credit if I did a backflip right now?
No. You might get extra credit.
You're sick.
I know it's terrible. I'm sorry. Just smack it on the table or something. Don't hurt yourself.
Oh,
You guys are having real
Are we
hard.
doing homework?
All right. Aiden is here. Evan is gonna be here. Dylan,
Just like Mr. Mac.
not here.
Huh?
Satan's here. Catherine. Is Catherine not here? No, she's here. Wait, those aren't her lights.
Accidentally. I had to.
Erica's not here.
Wait,
Jessica's
what's this
here.
for?
I was able to like skip the last step.
Was I supposed to grab this or not?
Carter is here. Wait, have we seen Aiden? No.
So we're not supposed to grab anything?
No.
Doesn't make any
Chill,
sense.
man.
Y'all
I'm just
always
ahead of the
think-
game.
Chill.
What were you gonna say?
Alex is here. Peyton is here. Coda is here. Alicia is here. Has anybody seen Aiden?
say at least two times?
I did it again. I'm sorry, Alicia.
Oh,
Okay, but he is gone.
At the
Okay.
bottom,
You better
from like one side and then do it two.
All right, slowest beginning to class ever.
I bet you play a lot.
We're told about every field trip like 2 months in advance, but like the ortho bus apparently wasn't important enough. All right, so today, first things first is the warm up. For those of you following along at home, this is what the warm up looks like. Okay, here's what the warm up looks like. It looks like,
No. How many viewers?
I don't know. Here's what it looks like. We got some cubes. That's step 2. Step number 3 looks like this. And step number 4 looks like this. There's a more efficient way of drawing these, but I refuse to obey.
There's no warm-up box.
All right. Yeah, because yesterday was Monday, so says me. So today is Tuesday. Today is the 5th all day.
What the heck?
Okay, I know.
Hey,
I
you
know.
don't have.
I know. This is a warm up, and so the idea is that we need to find a relationship between the step number 1, 2, 3, 4, right? It's a process, right? It's growing over time. We have different steps, and the number of cubes. Okay, this is a quote unquote simpler one than what we'll be doing at some point, right? But we want to start simple, even if it's tough for you and you don't get it. That's fine. That's okay. But we want to start simple that way we can start learning how to see. And not just how we see, but how math sees. So when we have the equation, what does the equation mean, right? So can you spot a connection? Try to figure it out. For example, again, I've listed them up here. N is 1. The block number B is 1, right? At step 2, the blocks total 3. At step 3, the blocks total 5. And you're probably seeing a pattern at the top, right? The number of blocks is always odd, right? And it goes up by 2 each time. How can we connect N, the step number, to B? Meaning that when I say, hey, step 43, how many blocks? You can pop that into an equation, and out pops the answer, right? That's the goal. And again, could you figure it out without an equation? Yeah, you could logic your way through it, right? But we're starting simple. That way when we get something that we can't just logically just look at and know the answer, right? 43, it's going to have 85 blocks, something like that, right? Then we can have a process to go about it. Because I feel like a lot of time in math class, it's either you get it or you don't, and if you get it, great, we move on. Everybody got it, right? They just saw it. And then when we get to the stuff you don't, we go, oh, crap, right? Like, now what? And the teacher goes, why don't you see it? Here's the example. Here's the metaphor. You ready for this? Okay. Here it is. I'm going to have to show you the delayed screen time here. That way everybody at home can play along too. Okay? What's up?
When do we get our test back?
Oh, you guys didn't get your test back yesterday. I will pass them out at the end of class. Remind me. Like 5 minutes before we go. So here's the deal. Okay? You ready for this? You ready for this? Okay. Here we go. You're only going to get a couple seconds to look at this. Are you ready?
Yeah.
All right. You're going to be in a little bit of delay, but that's on purpose. All right.
No, it isn't.
5, 4, 3, 2, 1. How many triangles are there? 3, 2, 1. Okay, it's gone. How many triangles did you see? Raise your hand. Tell me. Yeah. Go ahead. You said 3. How many did you see, Coda? 3. How many did you see?
3.
Anybody see more than 3 or less than 3? Yeah. 5. She's correct. Now, the difference between her and the rest of you morons, okay, isn't that she knew what a triangle was and knew how to count, and you didn't, right? You know what a triangle is, right? You know what a triangle is. You know how to count to 5. That wasn't the issue. But when you're presented with this problem, you feel like a moron because, I didn't see it, right? And the teacher calls you one because they're like, I see it. Why don't you? Right? But that's not the problem, right? The problem isn't you don't know what a triangle is. It's not that you don't know what the numbers are, right? It's that you didn't see what was going on. You saw 1, 2, and then the third one in the middle if you're lucky, right? But you missed these 2 guys. Or maybe you saw 1, 2, 3, but didn't see the big one, right? Maybe you're seeing close up the small ones, but not the big picture. Now, in normal math class, we give you a grade, we say, bad job, and you look at it and you wonder why, and oh, now I see it, right? And that's it. But in here, we're going to teach you how to see these things. We start out by practicing with something that's quote unquote simple. It's gonna be hard to see at first for some of you, and that's okay. We're gonna work through it. Again, you're not dumb when you make a mistake in here. You're not dumb when you see it incorrectly in a different way than somebody else. It means you just haven't seen it the other way yet. And we have to work on that perspective. And couldn't we use a little bit more of that, you know? So that's the goal for today. So I'm going to play a song. It's Radiohead, 2 + 2 = 5, which is a different way of looking at 2 + 2. Try to find a connection between N, which is the number down here, and then B, which is the total number of blocks, okay? You got a couple minutes, work together, think about it, come up with as many equations as you can to describe what's going on here. Hopefully you can get at least one. If not, that's okay. Yes? Yeah, warm-up sheets are back there. Oh, no, we're all out. Oh, no. Why don't I remember to do things anymore? All right. I'm very distracted lately. Here's a piece of paper. Knock yourself out, okay? Kere's the song, 2 + 2 = 5 by Radiohead. The album is Hail to the Thief. Hail to the Thief came out in 2003. Can't even say 20 something. I have to say 2000. It's that old. So Hail to the Thief is the album, and the song is 2 + 2 = 5. You have 3 minutes. Go. Yeah. Yeah. The shading, it's one way to think of it. It's not essential, but it's one way to think of it.
And this might be my warm-up trying to figure out how to solve this.
No.
The equation is
I'm going to screw that up in just a little bit, you know that, right?
You are?
Oh, yeah.
Why? Did you learn how to solve this?
No, because I have something to say.
Have you learned how to solve it then?
No, I'm waiting for the day when I can come up with my own algorithm instead of just like looking it up. Which will never happen because it's on the bottom of my to-do list. But I figure, what's the point otherwise?
Plus the IQ, you can't really learn that well.
Well, right. I mean, I'm not professional cute. Try to identify the connections between the n number and the number of blocks.
Yeah, that's good.
My advice to you is don't look at the big picture. But you want the small.
What's the question again?
How do these numbers relate to the number of blocks in each set? So if I plug in 5, and you plug it into an equation, pop out the total number of blocks. This is different. Okay? Don't feel bad if you can't figure it out. Try. See what connections you can find between the number below and the number of blocks that you see. It's all in how you count the blocks.
Wait, so like,
Yeah, you're trying to come up with an equation.
so like one can help to make a square.
Right, for instance, like, maybe I think it's this, 3n minus 5, right? It's not, because when I plug in 4, I get 12 minus 5. 12 minus 5 is 7. Oh, that looks good, right? 3 times 3 is 9, minus 5 is 4. Oh, man. Right? So what is it? My advice to you is you only need times, minus, or plus. That's it.
They can all make a square.
Like you add it all up.
Yeah.
That's a good observation. So those of you following along at home, Coda said if you take this piece and put them over here, that makes a square. You take these two, it makes a square. You put all these together here, it makes a square. Not what we're doing today, but that's really good.
They could not see it.
It is seeing it differently. 20 seconds.
So, is that what we're trying to figure out? Like, how to fit the other things together?
Alright, that was 2 + 2 = 5 by Radiohead. Alright, so what'd you come up with? Any ideas? We got one, we got an idea. Let's do it for YouTube. Man, I do not like this live stream format, but we're gonna make it work. Sorry, third hour, you get the short end of the stick here with all the delay. All right, so what did you do?
My equation is b equals 2n minus 1
Okay, so explain what B is. What does B stand for?
total.
Yeah, total number of blocks, right? B for blocks. Works for me. 2n plus 1. Or minus 1, you said. Minus 1. So minus 1. So why is it 2n minus 1? Let's check if it works, first of all. We plug in 1, we get 2. Subtract 1, we get 1. That's how many we need, right? 1 block. Plug in 2, we get 4. Minus 1, we get 3. 1, 2, 3 blocks. That works. Plug in 3, we get 6 minus 1. 1, 2, 3, 4, 5. 6 minus 1 is 5. Plug in 4, we get 8 minus 1, which is 7. 4 and 3 makes 7. So why does this work? I mean, it does, but why does it work? How did you count the blocks? What is this saying? This is a tough question. What is this really saying? This is a tough question. It's a hard question to ask because it's not one of these questions that I've learned how to phrase in the correct way to make you see the answer. This is a tough lesson. What else do you see? Anybody come up with something different? What'd you come up with? N minus 1 plus n. We'll have that equal b. Now, how did you come up with n minus 1 plus n?
I found out that the bottom loss, the basic one, which is the number of.
All right, this is beautiful. I'm going to repeat it for people watching at home. Okay, so check it out. She says n, this n right here, not this n, but this n, I think is what you're trying to say, is the same number as the bottom row of blocks. Does everybody see how 1 is 1, 2 is 2, 3 is 3, 4 is 4? That's a great observation. That's brilliant. Well done. Okay. And then what's the other part supposed to be?
And then the height of the side blocks are n minus 1.
Okay, so check it out. Let me rewrite this because I've goofed up the way you were saying it. So you said n minus 1 plus n. Let's have that. So this right here, this n, we should probably say, is the n that she's referring to. So ignore this. That's the n she's referring to. Let me scoot this up. Okay, so there's the n. And then the n minus 1 part here, that's the vertical part. Okay, now we don't count this, because if we count this, we count it twice, right? So that's not going to count. There's no vertical part here. That's what would go here, right? There's nothing. So that's 0. That's what n minus 1. N is 1. We subtract 1, we get 0. So there's nothing here. Now, vertical part here is actually 1, right? See how we already counted this? So that's the vertical part. Vertical part here is 2. Vertical part here is 3. So if this is 3, 2, 1, and then 0, 4 minus 1 is 3. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. So what she did is she counted it this way. She said, look at this one right here. She said, I'm going to add 3, and that's n, right? And then I'm going to add 2. Well, that's n minus 1. Over here, I add 4. Well, that's n for this one, right? And then I'm going to add 3. That's n minus 1. So it's n minus 1, the vertical part, plus n, the horizontal part. That's brilliant. Well done. That's what this means right here. It says take the horizontal part, I'm sorry, the vertical part right here, vertical, and then add it to the horizontal. Which makes sense, right? That's one way to count the blocks, right? I can count the horizontal parts first down here, and then I can add on the vertical. That's one way to count them. That's seeing it differently. Most people, when they count like this. 1, 2, 3. You said 2 plus 1, that's 3. 3 plus 2, that's 5. 4 plus 3, that's 7. Now, my next question, the question I want to ask is, what does this mean? How would someone count it like this? This is a tough question. This one makes sense. Horizontal plus vertical, right? This is the one that's interesting, I think. How does one count 2n minus 1? Another way to think about it. Let me get a clean piece of paper while you're thinking. They butchered that last one. What's up? Read my comments?
Yeah.
Are you leaving me comments?
Zed read left comment.
Oh, thanks, Zed. Was the comment the answer to the question? Okay, because I need you to figure that out. So Zed said B equals 2n minus 1. That's how he came up with it. Right? That was his formula. How does one count 2n minus 1? Remember, last time we had n minus 1 plus n. That's the vertical part plus the horizontal. You with me? What is this representing? Take some time to think about it. Yeah, Zed.
Well, what I thought was like the 3 on the bottom.
Okay, so we're looking at number 3. This one right here. Is that what you're talking about?
Yeah, that one.
This one. Okay, so focus on this one, everybody. Use this as an example. What do you see?
Oh, what I see is a 3 bottom, and then there's 2 up, but instead of instead of 3, instead of double,
Uh,
or will we still double it and then minus 1 since it's
okay, so check it out. Check it out, guys. 2n. He noticed. I know what you're saying. Let me try and put it into words, okay? Because you're right. There's a tricky way to say this, and it's very pedantic, but we're gonna get to it. So check it out. There's n blocks here, and there's n blocks here, right? 3 is n for this one. So we do twice that, right? There's 6 blocks total. If we go 1, 2, 3, and then we count 1, 2, 3. Now he noticed the center block, the corner block, gets counted twice. So we have to account for that, don't we? So we subtract it. Are we good? This is really important because we're not going to be able to do the warm-ups after this. This one is easy to see. The other ones are not. So I need you here. I know the comments are funny, okay? So we got 2 n's here. We have n here and n there. But we counted this block right here twice, so we have to subtract 1. So it's a different way of counting, right? When she counted bottom row, nothing in the vertical. Bottom row's 2, 1 in the vertical, right? So she always had 1 less in the vertical. That's what this represents here. 1 less in the vertical than there is in the horizontal. Here, he said, look, it's the same vertical and horizontal. You just can't count the middle one twice. So you have to account for that. You have to subtract 1. 2 ways of counting the blocks. 2 different equations. Now, here's where the algebra comes in and what we're doing today. If this is equation 1, that was Z's equation, right? And this is her equation. If they both equal b, then they should equal each other. See how this is equal to b? Right? So 2n minus 1 equals b. But this also equals b. So that means that these 2 bits must be equal. Look at that blue, red, and purple combo right there. 420, 69 IQ. All right, check it out. These must be equal. How can you prove it? You can prove it with algebra. How do you know these 2 are equal? I mean, we know because they have to be, but like, yeah, Danny.
They can cancel each other out.
They can, right? So we can subtract 2 n's from this side, gets rid of 2 n's over here. Then we have -1 equals -1. We add 1 to both sides, right? Gets 0, 0. That's true. That's great. Now, what if I said you weren't allowed to cancel things out? What if I said you had to keep things on both sides where they are? Blue stays with blue, red stays with red. You just need to make them look exactly the same. Because if they look exactly the same, then they are the same, right? Go ahead.
combine the like terms on the inside.
Okay, the red side? Okay, so over here, we're going to keep this the same. Whenever you do an algebraic proof, it's preferred that you take one side and mess with it and the other stays the same. Okay, you just leave it alone. If we can make this side look like that side, then they have to be the same, right? So check it out. He says combine like terms. What are my like terms over here? Yeah, Z. The n. So we have positive n and positive n. How many n's is that? That's 2 n's. And the -1's still there. Are you seeing it now? That's what algebra is. It's taking something that is the same. That's what an equal sign means. They are the same. Same dumb thing. And making it look different. Because a different way of looking at it is a different perspective. And the more perspectives we have, the more interesting ways we can count things and come up with different ideas. Ideas that look different, right? I'm going to do this, double it, and then take away the middle. That way I don't count it twice. I'm going to count the bottom, and I notice that the top is always 1 less, right? 2 different ways of thinking that end up being the same thing. I feel like a lot of times when we disagree with people, we don't really disagree. We misunderstand. We're saying the same dumb crap. We're just saying it in a different way. And that's what perspective can provide for you. That's what we're doing in here. That's the magic. Also, there's a Jewish phrase. I can't remember the Hebrew for it. But the phrase is translated loosely, turning the gem. And what it means is when you hold a gem up to a light, it refracts, right? And that refracted light goes from white light to a different color light. Maybe a lot of different colors. And if you have a really good gem, you should be able to turn the gem in any way that you want. And eventually, after turning it every possible way, you've seen every possible color. It's all the same gem, just a different way of looking at it. And that's how you should live life. And that's what we're going to do with algebra. We're going to take an equation, a really basic one. We're going to turn it every possible way and think about what does it mean now? It's the same thing. It's all white light. But we're highlighting the different spectrums. All right. So today, algebra. Here's the review of last year in a nutshell. I'm going to pass it out now, okay? Should look something like this when you get it. We're going to do a lot more with these types of warm-ups, okay? Seeing it is the hard part. You should not feel dumb if you don't. It just takes some perspective. We can teach that. All right, here we go. All right, it's 2 pages, like 2 physical sheets of paper. They're not stapled. They're maxed out.
They're max style.
Do you have another one?
Oh,
What's your other one?
oh.
So the last 2 terms are good.
Guys,
Guys, we have one more interesting idea. Oh, sorry. We have one more interesting idea before we go on. The storm, I didn't call on you because I didn't think you could talk today. I thought you were still sick leave. I'm glad you are.
I'm down for it. Go ahead, Lynn.
All right. So before we get into this, Autumn's going to talk about her idea.
wait.
Are you missing a page?
No.
We're good. All right. So Autumn has another idea before we go on.
Oh, crap. That's sorry.
What? The stapler? Yeah, I know.
I know.
It's the only one we got, guys. It's the one I found in the dumpster. Here, let me fix it.
If I just hit it,
Here. All right. No one's framed. Okay. You ready? Here we go. Stand back. All right.
Wait, what did you just do? I missed it.
He just slammed it
Right now.
into that.
Done. I told you it works, right? No, staple it yourself. You freaking
buffoon.
All right. Yeah, you buffoon. All right. So, hi YouTube. Please unlike, please unsubscribe, leave a mean comment, cancel our channel, unring that bell. I just smacked a kid with a stapler. That's what you just heard. All right. So Autumn has another idea for how to count these. So let's draw this real quick because I'm a failure as a teacher right now.
Genius. You can respond to your comments.
Yeah, I know. I never respond to the comments. Isn't that the rule? All right.
Dude, that's unloyal.
It is unloyal.
Unsubscribing now.
Unsubscribe, unlike. All right. So Autumn has another way to think about it.
I'm
So
unsubscribing.
Autumn, tell us about how you thought about this.
Well, if you want to just add the 3 and the 4 and you get to 7.
So check it out.
I won't sound good.
She's saying to know how many are here. There's 7 blocks, right? All you have to do is look at the last one, 3, and add it together with the one you're on. How do we know this one? We look at the last one and we add it together with what we're on. How do we know this one? We look at the last one and we add it together with what we're on. What about this one? To figure out this one, you look at the last one. What's the last one? 0. Add it together and we got it. This is called recursion. This is very common in computer programming where it says look at the last thing and then do this to it. It's a very brute force way of getting stuff done. It sucks because if I wanted to know the 43rd step, well, I'd have to know the 42nd, right? And then I'd have to know the 41st, and I'd have to know the 40th, right? I'd have to keep going back until I found one that I found, right, already, and then work my way back up. So this is kind of a pain, but for computers, it works really nicely because they can work so fast, right? This is called recursion. We're going to talk about this later. Autumn, that was beautiful. Well done. Well done. All right, so now let's get into the worky sheety because that's what math is all about is the homework, really. So here we are. Look at number 1. We've got 2 variables in one equation. It says rearrange each equation and solve for that variable. Let's make this a big screen. Let's make it a big one. You get rid of those comments so you guys can actually focus. Here's what we're going to do. I'm going to copy down the problem and make it nice and big. That way everybody can see what's going on. So number 1, taking a gander, we're making it thick. So 2x plus 1 equals 3y minus 5. Everybody cool? Can't see it yet. Oh, it'll be there. You just got to be patient. Live stream sucks, man. Seriously. All right, so here we are. Now,
That's a bag.
lesson in algebra. We have two terms over here, 1 and 2, right? Terms are separated by what? Talked about this yesterday. What?
Nothing.
What are terms separated by? They're always separated by what or what? Danny.
A symbol.
A symbol. What kind of symbol? Not just any.
Plus minus.
Plus or minus. So we have two terms here. We have a minus there, so we have two terms here. Now, when we move terms, listen to the verb. Verbs are important. When we move terms, we either add or subtract them. We do it to both sides. Remember, if we do it to one side, that's against the laws of algebra. We cannot violate the law. But if we do it to both sides, it's fine, right? It's like child abuse. If you push one kid over, that's bad. But if you push both kids over, it's fair. So says algebra, right? So we have to do it to both sides, whatever we do, and everything that's there, okay? When we move terms, we either add or subtract. So if I want to get x on its own, right, because that's the whole point of math, get our x's on their own, I want to move everything that's bothering the x to the other side. Is the 3y or the minus 5 bothering the x? No, they're already far away, which is the whole point of math, to make people go away, right? So we did that. The 1 and the 2 are bothering the x. Now, here's the thing. PEMDAS is a lie. You can do anything in any order you want. Everything is permissible, but not everything is beneficial, okay? I would suggest that we move everything first. Because when we get rid of that 2, how are we going to get rid of that 2? You say subtract. Of course, right? It's positive, so we need to subtract it. Wrong. Here's why. If we subtract it, we move the whole term. So what is that going to move with it? It's going to move the x. And do we want to move the x? No. We want the x to stay and everything else to go away. So here we're not going to subtract the 2. We want to separate the 2 from the x. See how they're one term, they're one item, they're married in holy matrimony. We need to separate them. Home wrecker, home wrecker. How are we going to break them up? Yes.
You divide the 2 to everything.
Yeah, so we divide to separate, right? Separation is divorce, divorce is division. What happens when you get divorced? Everything gets divided, right? So when we divide that 2, every term gets divided. They always say do it to both sides, do it to both sides, right? That's not enough. You have to do it to every term on that side. That's how divorce works. The more stuff you have, the more things get divided, right? And we've got a lot of stuff. So let's move our stuff out of the house, and then we can worry about divorce, right? That's a lot better. Prenup. All right, so let's move the 1 first. Again, you can do whatever you want, but I'm going to show you what I would do. I'm going to move the 1 first. How do we move things in math? We either add or subtract. What are we going to do for the 1? Subtract because it's positive. That makes sense. So we do it to both sides, and we get 2x equals the stuff that's already there, but we have to subtract it from this side, right? So now I'm going to subtract 1 from over here. Now, is there a better way to say something minus 5 minus 1? Is there a more efficient way to say something minus 5 minus 1? Yeah. Something minus 6, right? Do you see why those combine? It's just a shorter way of writing it. You could have written 3y minus 1 minus 1 minus 1 minus 1. You know, you could have done that too. But, like, let's not. So now we're here. And now everything is moved out of the house except we need to get the divorce, right?
Yeah.
So it's time to divide. And when we divide, remember it's divorce, everything gets divided. So this term and this term and this term gets divided. So let's do that. We divide this side by 2. That gets us x. That's the whole dumb point, right? To separate the x from the 2. Separation is divorce. Then we divide the 3y by 2. What's 3 divided by 2? 3 over 2. Remember, fractions are just division for lazy people. Don't write 1.5. That's awful. Writing decimals in here, that'll be terrible to mess with. Do what you want, okay? But this will be a lot easier, and I promise I'll show you someday, okay? We're getting to that. Maybe tomorrow. 3 divided by 2 is 3 halves, right? Maybe you know 1.5 off the top of your head, but what if that was a 7? Then you got to think about it, don't you? Why think about it? Write 7 over 2. What's negative 6 divided by 2? Remember, every term gets divided by 2. What happens? Negative 3. Okay? Everything got divided by 2. The x did, the 3y did, and the negative 6 did. That's divorce. Now x is on its own, so we have solved for x. X equals a bunch of junk. Sometimes you get x equals 4, right? Other times you get x equals 3 halves y minus 3. It's okay. It's solved for x. Now there's another way we could have done this. I told you, everything is permissible. You're allowed to do it. PEMDAS is a lie. But not everything is beneficial. So check it out. Starting from here. What we did first was we subtracted the 1, right? That's great. That's wonderful. It makes it easier to do that divorce, right? But what if we wanted to divide first? You have freedom in algebra. You don't have to obey PEMDAS. It's a lie, okay? Think for yourself. You don't. As long as you do it right, you're fine. As long as you know what's really going on. That's good. That's good. Because that can be helpful. Okay? That's good. There was a reason we taught you that. Now, check it out. What if we divided by 2 first? What happens in divorce? Yeah. Divide everything. So the 2x gets divided by 2, the 1 gets divided by 2, the 3y gets divided by 2, and the 5 gets divided by 2. So check it out. I divide this by 2, I get x. What's 1 divided by 2? 1 over 2, right? What's 3 divided by 2? 3 over 2 with a y. What's 5 divided by 2? 5 over 2. That's it. Fractions are division for lazy people. Don't pull out your calculator and figure out that 5 divided by 2 is 2.5. Okay? It's a waste of time. Now we're here. X is almost on its own. We just got to get rid of this thing. So we need to move it, right? How do we move things? Subtract or add. This one's going to subtract. So we get x equals 3 halves y minus 5 halves. The thing that's already there, right? Minus the thing we moved. Well, what did we move? We moved the half. So it's minus a half. Now check it out. If I've got negative 5 halves and I'm taking away 1 more half, how many halves have I taken away total? 6 halves, right? I can subtract 5 halves and then subtract 1 half, or I can just subtract 6 halves all at once. So I'm going to write it like that. X equals 3 halves y minus 6 halves. Now, ladies and gentlemen, give it a second for it to catch up. What's another way to write 6 halves? Minus 3. Now, if what we did was allowed, then it should be the same as what we got before. X equals 3 halves y minus 3. Same thing. As long as you know what you're doing. The reason we teach you PEMDAS is because we know you're going to screw up and you're not going to divide everything by 2. We also know that you fear fractions because we taught you it that way to fear them, basically. But you don't have to. I've got 5 halves, right? Now we have another half. 6 halves. That's it. This is solved for x. Let's go solve for y. So same problem. This time we're going to get y on its own. So check it out. Number 1 is 2x plus 1 equals 3y minus 5, right? That was our original problem. Delay is awful. I'm going to get y on its own. Is the 2x plus 1 bothering the y? No, it's not, is it? So we're going to leave it alone. What is bothering the y? The 5, the minus 5, and the 3. We can do anything we want. But if you don't like fractions, it's usually good not to institute division, because remember, fractions are just division. So let's get rid of the 5 first. We need to move it, right? How do we move the 5? We add it because we're moving it. We're moving a term, right? That's a term. We're moving the whole term over. So we add 5, and we get 2x plus 1 plus 5. What's another way to say plus 1 plus 5? Plus 6 equals 3y. Can you see that yellow? Okay. Now, it's time for divorce. We need to divide by 3 because we need to separate the 3 and the y. See how they're one term? There's no plus or minus separating them, right? They're one item. Holy matrimony. We got to break them up. We do it by division, not subtraction. I know it's positive, okay? We do it by division. So we divide everything by 3. So the 2 gets divided by 3. What's 2 divided by 3? 0.66666666. Yeah, good luck writing that down, right? How about 2 over 3? Decimals suck, man. What's 6 divided by 3? 2. 3 divided by 3 is 1. That's why it's gone, right? That's why we did it. It better go away, right? And now we're solved for y. Right? Now, could we also write it like this? And there it is. That was the delay. Can we write it like that too? Yeah, right. If I'm true forward, and it should be true forward and backwards. If I say 8 equals 5 plus 3, doesn't 5 plus 3 equal 8? Yeah. Same forward and backwards. Doesn't matter. We don't need to move stuff around. Just flip it. All right, number 1 wasn't too bad. Let's get into something a little bit harder. Let's take a look at number 2. X over y, or xy over 9 equals 2p. All right. Yeah. So pass quizzes out. All right, we'll do that. I want you guys to try this. You're going to struggle with it, okay? There's going to be a lot of struggle, and then tomorrow we'll go through the whole thing. Your quizzes. Here they are. Better than you probably thought for some of you. The bigger score is your score as always. Danny. Alicia.
Let's go.
Peyton. Carter.
I think I did good on it.
Coda.
Didn't do good.
Storm.
Let's go.
Zayden. Cheyenne. Scott. Evan. Not here. Erica. Not here. Jess. Or do you not prefer Jess? Which one is it? You prefer Jessica? Okay, I couldn't remember. Dylan's not here. Xavier. Anderson. Paige is not here.
Dang it.
Bro, I'm so happy.
All right, did everybody that took the exam get an exam? You did not? Zed, did you take the exam during class? Then why don't I have yours, Zed? When I was gone? Oh, then I have the grade still. That was yesterday, right? Or 2 days ago? Yeah. So I still got a grade. I'll grade it this weekend. Here's the deal, okay? Pretty good quizzes overall. You knocked them out of the park. If you got an A, I scan it. I send an email to your parents and tell you to buy, get ice cream. Put it on the fridge. This doesn't happen a lot. Well done. Some of you guys forgot to do distance formula. That killed you. Other people didn't know how to do distance formula. That also killed you, okay? First one was midpoint formula, 1 to 1, right? Super easy. Add them up, divide by 2. Second one, the ratio was 2 to 5 because it's 2 out of 7, right? So M and N were 2 and 5. And you need to do that formula correctly. The third one, not a hard problem, but a lot of people struggle with it. If you're struggling with it, come see me. It's a very easy fix. I feel like if you made mistakes, they were small ones that caused huge issues. And because they're small, it's hard for you to see because you're not used to finding those small little mistakes. You're not a math teacher. So come see me. I'll point out those small mistakes. We'll fix them because they're so small, they're easy to fix. And your grade will increase dramatically. Nobody in here did I grade their quiz and think like, oh man, they just don't know what's going on. Okay? It was small stuff. Feel good about that. Yeah.
Did we get
Self-development points?
Yeah.
Yes,
Put a
it doesn't
smiley face on
factor.
it?
No, it's good. I don't factor that into your quiz. Remember, that's a separate grade. You need 10 points per semester.
So I got 3.
There you go. Remember, if you come and see me for help or a retake or any of that stuff, you also get self-development points.
I should have gotten like 1 then that one day.
I've got stuff written down. You should be all right.
Let's go.
Okay? It's not hard to get 10. I should have made it 20, right? It's ridiculous how easy it is.
Should have made it 5.
You should tell me how much I have after class.
we should do
Okay,
number 2
it's on
on
a
the
sticky
board.
note somewhere. If you need a retake, if you got lower than 65, you need to fill out the form. Come talk to me. Make sure all the homework for the week is done. The quiz review is done. Then we'll do a test on the board. And if you can ace that without wasting my ink, then I'll give you the real one on a different day. If you want to retake it and you got higher than 65, just to do better, come see me. I'll give you a quick little pre-test, and if you're good, we'll do it on another day. You get a higher score. Can't get a lower. What do you think about that? Are we good? Questions, comments, concerns?
Can you do number 2 on the board real quick?
Like this one?
Yeah.
This-
Isn't it like x, y equals 8?
All right, which one do you want to solve for first? P, X, or Y?
P.
Solve for P. So what do we got to do to separate the 2 from the P?
Divide.
Divide, right? Not subtract, divide. So we divide. So we have XY over 18 equals P. And here's why. We have something divided by 9, and then we divide it in half. So check it out. You know what pizza is, right? Okay, so check it out. That's a pizza. It'll be on the screen in a second. If I divide pizza in half, I get this, right? Now we got to wait for me to catch up to myself. And then I divide the pizza in half again. The same as dividing it into quarters to begin with, right? There we go. Yeah, this has to change next week. So dividing it in half and then dividing it in half again is the same as just dividing it into quarters. So if I divide it into ninths and I divide it in half, it's the same as dividing it into 18ths. Think about it. I have a ninth of something, then I cut that in half. I've now got an 18th. You dig? So the 2 goes on the bottom with the 9 and they multiply. Bound chicka, wow, wow. Okay? P is on its own. Now let's get X or Y on its own. Let's go back to the beginning. What's bothering the X or the Y? The divide by 9. How do we undo division? Multiplication, the opposite of divorce. Bound chicka, wow, wow. Right? So we get Y equals 18P. Because 9 times 2 is 18. Now which one do you want to get on its own, X or Y? X. Are X and Y separate terms over here? Are X and Y separate? No, they're an item. Time to home wreck. We got a divorce, right? So we're going to divide by X or divide by Y. If we go after X, we need to move the Y, right? We need to get rid of the Y. So let's divide it. Both sides divided by Y. Everything gets divided by Y. What's 18P divided by Y? Fractions are division for lazy people. 18P over Y is 18P divided by Y. That's it. Now, using that logic, if we divide by X to both sides, 18P over X is what we get, yeah? And there it is.
How many solutions do you want for each?
3, 1 for each variable. Solve for X, solve for Y, solve for P.
So you solve for 2 of them. So you just gotta solve for P for them.
Well, we already got P, right? Didn't we get that earlier? X, Y over 18 equals P.
Oh, okay.
This delay is killing this class. It's awful. All right, look at number 4 real quick. Number 4 is 5 equals P over X minus Y. Okay, so take a look at that. Let's get P on its own. Ladies and gentlemen, instead of X minus Y on the bottom, if that was a 2, would you know what to do?
You do 5 times 2, then you get 10.
We times by 2, wouldn't we? So we're not going to times by 2, we're going to times by what? We're going to multiply by X minus Y, the quantity, because there's 2 terms here, right? An X and then a minus and a Y. So we're going to multiply by X minus Y to both sides. So what does that do? Well, dividing by whatever X minus Y is and then timesing by whatever X minus Y is cancels, right? Dividing by a number and then multiplying by that number just gets you the number you started with, which was P. Over here, we have 5 times the quantity of X minus Y. Jeez, this is taking forever. There we go. So once we're there, P is on its own and we're done. Now let's go get X or Y. I'm going to start here where we left off, okay? The 5 is bothering the X and the Y, right? That 5, is that separated by a plus or a minus? No, so we're not moving it. It's not a separate term, is it? This is one term. That whole thing is one term. In there, there's 2 terms, but we have 5 times a something, right? That's what the parentheses mean. So that's one term. So we need to separate. We need to divorce, right? So we get X minus Y in parentheses left over. After we divide by 5 to both sides, we get P over 5. So now we're here. Do we need parentheses anymore after we've divided by 5? No, the only thing over there is X minus Y. So I'm going to write it without the parentheses. And now, X and Y are separate terms, aren't they? How do we move terms? Add or subtract. So if I want to get X on its own, what am I going to do to the Y? Add it. So X equals P over 5, the thing that's already there, plus the Y I moved over. Try the rest on your own. Yeah, we can't do the delay thing anymore. I need to get 2 cameras or find out a different way to run a video.
We'll do the test over there.
Yeah, leave the test on your desk. I'll grab it, okay? Get out of here. Yeah, leave your test behind. Do not take it.